You ever stop and wonder what actually keeps our power grids from failing? Or how factories turn out products with perfect consistency? Or even how the water coming out of your tap gets clean? Well, behind pretty much every single one of those massive industrial processes, there's this hidden world. A world of sensors, controllers, and automated systems, all working silently in the background. And today, we're going to pull back the curtain on that invisible world. We're talking about instrumentation and control, the hidden nervous system that runs, well, everything. So to really get why this system is so critical, we got to start with the problem it was designed to solve. Because let's face it, for any industry to really scale up and get big, relying on just human hands and eyes, it just doesn't cut it. There are some serious fundamental limits to doing things manually. And this right here, this shows you that shift perfectly. On one side, you've got the old way, manual labor. I mean, it works, sure, but it's got obvious limits, right? Speed, precision, just plain getting tired. But on the other side, that's automation. It's faster, it's relentlessly consistent, and it can go 24/7 without a coffee break. This was the massive leap that industry absolutely had to make. Okay, to make this a little more real, let's paint a picture. Imagine a small craft brewery. You could probably have one person running the show, right? They're watching the tank levels with their own eyes, turning valves by hand, just kind of making sure everything's ticking along. And for a really small setup, you know what? That totally works. But what happens when that person's phone buzzes? Or when it's the end of a long 12-hour shift and they're just exhausted? The reality is humans get distracted. We make mistakes. It's not if a tank overflows or a batch gets ruined, it's when. And when you scale that up to massive industries, those tiny little errors can lead to absolutely huge costs and sometimes really serious safety problems. So what's the fix? Well, it's simple, really. You give the process the ability to watch itself. By just installing one simple level sensor, you're swapping out a person's guess, their subjective observation, with cold, hard, reliable data. And that right there is the first, most crucial step toward building a fully automated system. And that one little sensor, it unlocks a much, much bigger idea. See, we're not just putting a Band-Aid on one problem anymore. We're actually starting to build an entire automated system. This is where we get to what you could call industry's hidden nervous system. Which brings us right to our main topic, instrumentation and control. Seriously, the absolute best way to think about this is like a nervous system for a factory. It's what lets all the machinery sense what's going on around it, think about what needs to happen next, and then act on that decision, all without a person lifting a finger. And here it is, that whole nervous system in action. Check it out. The level sensor, that's our sense organ. It notices the liquid is getting low. It shoots that info over to the controller, that's the brain. The brain processes it and goes, whoa, level's too low. Got to turn on the pump. And then bam, it sends a command to the pump, the muscle, to get to work. This simple loop, sense, think, act, that is the beating heart of all automation. All right, let's break that down even more. The anatomy of pretty much any automated system has these three key parts. First up, you've got the sensors. Think of these as the senses, the eyes, the ears, the nerve endings of the whole operation. Then you've got the controller. That's the brain, the thing that takes in all that sensor data and actually makes the calls. And finally, you have the final control element. Stuff like pumps, valves, motors. These are the muscles that carry out the brain's orders. Senses, brain, muscles. Super simple when you think about it like that. Okay, so we've got our senses, brain, muscles framework down. Let's dive into the first part. The senses. If these sensors are the eyes and ears of the machine, what exactly are they sensing? What are they looking for? Well, in the world of control systems, we call these measurable things process variables. And man, they can measure a huge range of stuff. We can kind of group them into a few buckets to make it easier. You've got your physical variables, things like pressure, temperature, level, and flow. Then you have chemical variables like the pH of a liquid or its conductivity. And of course, there are mechanical ones, like how fast a motor is spinning or how much it's vibrating. So we've got all these different variables, physical, chemical, mechanical. Let's go on a quick tour of some of the most important industrial senses out there and see exactly how these machines feel the world around them. All right, let's kick things off with a big one, a really fundamental force: pressure. We're talking about the measure of force on a surface, and it is absolutely critical in, well, almost everything. From massive pipelines carrying natural gas across the country to the delicate reactors that create life-saving medicines. But here's the thing, pressure isn't just one single measurement. It's a bit more nuanced.
Sensors can measure what's called gauge pressure, which is just pressure relative to the atmosphere around us. Or they can measure absolute pressure, which is measured against a total vacuum. And then there's differential pressure, which is super useful. It's just the difference in pressure between 2 points. You can use that to figure out things like flow rates or even if a filter is getting clogged.
Next up, another absolutely critical one: temperature. Think about it. From pasteurizing the milk you drink to generating massive amounts of power in a steam turbine, so many processes depend on hitting and holding a super precise temperature. We're often talking fractions of a degree here for things to work right. So how do they do that? Engineers have a few different tools in their toolbox. Two of the most common are thermocouples, which are pretty clever. They actually generate a tiny electrical voltage based on heat, and RTDs, which stands for resistance temperature detectors. Their electrical resistance changes as they get hotter or colder. Both of these are basically what give a machine its own precise sense of hot and cold. Okay, our third key sense is flow. It's exactly what it sounds like, measuring how much liquid or gas is moving through a pipe in a given amount of time. And this is crucial for everything from your water company billing you correctly to a factory mixing the ingredients for your favorite soda just right. So, how do you measure something that's moving inside a sealed pipe you can't see into? Good question. There are basically two ways to go about it. The first is obstructive methods, where you literally stick something in the pipe, like a tiny turbine, that spins as the fluid goes by. But the more advanced way is non-obstructive, using cool stuff like electromagnetism or ultrasonic waves from outside the pipe. That way, nothing gets in the way of the flow at all.
Okay, so we've touched on sensors for pressure, temperature, and flow, but let's pull the camera back for a second. Let's zoom out. Why does all this matter? Who cares if a machine can feel these things? What's the big picture here?
Well, the simple fact is, this stuff, instrumentation and control, it's the absolute backbone of modern industry. And that's not an exaggeration. Just think about it for a second. Oil and gas refineries, massive chemical plants, power stations, pretty much any automated factory you can imagine, not a single one of them could run safely or efficiently without these systems watching and adjusting everything, every single second, in real time. And the benefits? They're just huge. You're improving productivity and making a better, more consistent product. You're slashing the number of costly human errors. You're making things way safer by getting people away from the dangerous parts of the job. And at the end of the day, it saves an incredible amount of money and resources.
You know, there's this saying in engineering that just sums the whole philosophy up perfectly. It goes, the goal is to have the process running, not the people. It's all about letting machines do what they're good at, that precise, repetitive, tireless work, which frees us, the people, up to focus on what we're good at, thinking, designing, innovating, and making the whole thing better.
So these systems really are the foundation. They give machines the power to sense and react to the world with a precision we could never match. And that kind of leads to one last question, a final thought to leave you with. Now that our machines can see, hear, and feel the industrial world, what are they going to learn to do next? What incredible new levels of intelligence and autonomy are waiting for us just around